Hey guys, here we have an exam paper. If you want to download the paper, just check the description below this video. Here we have a multiple choice. Now, this one's super easy because we know that anything to the power of 0 is 1. So immediately, the answer has to be 1, no matter what is in that bracket. Written below are two statements about a number pattern. The first term is 8, okay. The difference is 2. So that means that each time you go to the next one, you will add 2. So the next number would be 10. Then you would add 2 again. And then you would add 2 again. So it would go 8, 10, 12, 14, and on. So it must be D. Given the expression m3 plus 3m squared plus 5m plus 2, the coefficient of m. Okay, so we go to the m, which is over here, and we look at that part over there. So that's a 5. So that's that. Determine the value of the following. Now, technically, this is a multiple choice, so you can literally just go throw all of that on your calculator. So I'm going to try and make your lives easier. Go do that. Just go put it all on the calculator. Make sure you type it exactly as you see it, and that should give you 9. If you were ever in a test where your teacher said no calculator, that hardly ever happens, but the way you would solve this is the following. You would leave this negative alone, so you'll just say 3 minus. Now, inside here, what is minus 5? Add 2. Well, minus 5 add 2 is minus 3. Okay? Now, here we have a minus and a minus next to each other. That becomes a plus. So we're going to say plus, okay? And then plus 3, and that'll give you 9. Some of you might have thought, don't we need to multiply these two numbers? No, that would only be if it looked like this. Can you see the difference between that and that? Here, the 3 is right next to the bracket. Here, the minus separates them. So they're two very different things. For which value of t is the following thing undefined? Undefined, I want you to see the word under. So go look under. And I want you to make that under part equal to 0. That is what undefined means. It means when the under part of the fraction is 0. Now you just need to solve. How would you solve this? Well, I would take this minus 2 to the other side. When you take it to the other side, it changes from a minus to a plus. Then to get t by itself, I would need to get rid of that 2, so I divide by 2. But what you do on the one side, you have to do on the other side, and so t is 1. The following table shows multiples and factors of 30, 75, and 100. Let's quickly take a bit of time and remind ourselves what factors and multiples actually are. I'll show you on the next page. I'm going to take the number 30 and let's go talk about that. So let's take the number 30, like we said. If we go look at multiples, that means you are going to count in 30s. So 30, 60, 90, 120, 150. You see how we're counting in 30s? Now let's talk about factors. Factors are the numbers that fit inside a number. Numbers which fit inside a number. Okay? So that would be things like we always start with, I like to do it like this. You take the number 1. How many times can the number 1 fit into 30? Well, that would be 30 times. Then I try the number 2. 2 fits in 15 times. Why? Because 2 multiplied by 15 is 30. Then I try the number 3. Well, 3 times 10 gives me 30. Next would be to try the number 4. But the number 4 doesn't work because you can't multiply 4 by anything to make 30. 4 times 7 is 28. 4 times 9 is 36. So it doesn't work. Then I try 5. I know that 5 times 6 gives me 30. Then I try 6. I already have a 6, and so I stop there. So make sure that you've got the same number here. You've got 4, and here you've got 4, because each one has a partner. Okay, each one has a partner. So how many factors are there? 8. There are 8 factors of 30. Okay, so let's now go back to this question where they've listed all of these things for us. We can see the numbers 1, 2, 3, 5, 6, 10, 15, 30, just like we had 1, 2, 3, 5, 6, 10, 15, 30. Okay, And with the multiples, you can see 30, 60, 90, 120, 150, and so on. Then they've gone and done that with 75 as well as 100. Okay, now, the first one says, write down the highest common factor of 30 and 75. Okay, so that means this part is out, and it also means this part is out. They only want us to look at the factors, and they want us to look at the number 30 and 75, and they want us to find the highest factor. So what is the highest number, the largest number that you can see in both of these? Well, the largest number that I can see in both is the number 15. So that would be the answer there. Now it says write down the LCM, the lowest common multiple of 75 and 100. Okay, so we don't have to look here and we don't have to look here because they're only looking at multiples now. But now they want the lowest common multiple. So what is the smallest number or the lowest number that you can see that is in both of these? Well, I see it as 300. Can you see that is the smallest number that is in both? So that would be 300. This number is between which two whole numbers? Now this is a very easy question. All I want you to do, take your calculator and just go type this in. Okay. If you struggle to find this on your calculator, if you have a Casio, you see how you have a square root button on your calculator? That won't work. First press shift, then press the square root. Then you'll see it opens up at 3. If you type that in, you're going to end up with 2.466, and it goes on. So can you see the number 2? So that means that this number here is between which two normal whole numbers? It would be between the number 2 and would be in between the number 3. So somewhere in between 2 and 3, you would get this number. So the answer is 2 and 3. Is this number rational or irrational? Okay, so let me give you some examples of rational numbers. So if I have the number 1.43, that is rational. Why? The decimal stops. Okay, if I have 1.363636, so that was a 6 over there, 36, and it goes ... that is still going to be rational. Why? Because decimal has a pattern. Can you see the pattern? 36, 36, 36, 36. So even though the decimals don't stop, it still has a pattern. So if the decimal stops or if there's a pattern, then you can say that it's rational. Other things that are rational would be any kind of fraction, all fractions. Okay, so what if I have the number 1.6812? That is still going to be rational because even though there's no pattern, we can say that the decimal stops. What about 1.7812361124 ... Here we will say that this is irrational. Why? Decimal does not stop and there is no pattern. You see there's no pattern here. There's no pattern that I can see. Here I could see a pattern. 36, 36, 36, 36. So I hope that that helps you. And then also normal numbers are rational. 5, -3, -2, 0. All of those normal numbers are all rational. Okay, so if you go type this in on your calculator, it's going to give you 2.466212074. Now some of you might say, oh look, it stops. So that means it's rational. However, your calculator cannot show the numbers going on and on and on because a calculator only has limited space. So can you see that they've used up all of the spaces on the calculator? So that means that these numbers actually want to keep going on. And so this thing, the decimals do not stop and there's no pattern over here. So this is definitely irrational. Determine which of the 4 tables gives direct proportion. Justify your answer for 3 marks. Okay. So, with the word direct, or with direct proportion, I want you to look at the D in the front and remind yourself, divide. You should be able to divide the Y and the X and you should get the same answer. So, for example, If I show you this one, what is 12 divide 3? That'll be 4. What is 20 divide 5? 4. What is 32 divide 8? 4. What is 48 divide 12? 4. And so that is direct proportion. You would not be able to divide these other ones and get the same answer every time, okay? And for example, here you could say 5 divided by 4. That would give you 1.2, I think. 5 divided 4, yes. Oh, no, 1.25, sorry. 1.25. If I then say 15 divided 8, that doesn't give you 1.25, so it's not that one. So you're going to say that the answer is table C. And your reason, because they said that you must justify your answer, just say that y over x remains constant. You see how we kept getting 4, 4, 4, 4. You can also use x over y. You could also go calculate x over y, and what you would have found is that every time you would have ended up with 1 over 4. So for example, if you said 3 over 12, you would have got 1 over 4. 5 over 20, 1 over 4. 8 over 32, 1 over 4. 12 over 48, 1 over 4. That's also allowed. Okay. It takes Sandile 6 hours to fill one tank with water. Okay, let's draw that out. So here we've got a tank, and Sandile, let's put a person over here. If Sandile fills this up with water, okay, so there's water. In order to fill it up completely, it would take 6 hours. Okay? And this is for Sandile. Now, Jacob takes 12 hours. Okay, so Jacob takes 12 hours to fill up the same size container. So maybe Jacob is a little bit smaller. Takes a bit longer. So Jacob takes 12 hours. Okay. If they work together, how long will it take? Now, think about that carefully. The answer is not going to be 6 plus 12. That makes absolutely no sense, but I know a lot of learners say that without thinking about it. Think about this quickly. Sandile, when he works by himself, he can take 6 hours. Now, if little Jacob comes along and says, hey, can I help you? Don't you think the 6 hours will become even less? Because even though Jacob is a little bit slower, he's still going to be helping because he's still going to be throwing some water in. So Sandile can do it in 6 hours when he works by himself, but now that Jacob is there, it's going to be even faster. So the answer is definitely going to be less than 6 hours. Okay, so I need you to think about this very carefully for me now. What we're going to do is we're going to break this all down into 1 hour. Okay, so what fraction of this container can Sandile fill in 1 hour? We know that it takes him 6 hours to completely fill up that tank. So would you agree with me that in 1 hour, he would fill in 1/6? In 2 hours, he would fill up another one. So now he's done 2/6. In 3 hours, he's done 3/6. Okay, I haven't spaced this out nicely. But in 4 hours, he's done 4/6. In 5 hours, he's done 5. And then in 6 hours, he's filled up the entire tank. So in 1 hour, Sandile can fill up 1/6 of the tank. A sixth. Okay? Jacob, in 1 hour, can fill up a 12th. So Jacob can fill up a 12th. So in 1 hour, how much of the tank can they fill up? Well, you just add these two together. So in 1 hour, if you add 1/6 plus 1/12, you could do this on your calculator. If you're not allowed to use a calculator for some weird reason, then you need to get a common denominator. So do that however you're allowed to, like however you have to do it, but you should eventually, after you've simplified, you should end up with a quarter. Okay, that should be your final answer after you have simplified. So listen to this carefully. In 1 hour, they can fill up a quarter. So that means in 2 hours, they would be able to fill up 2 quarters. In 3 hours, they would be able to fill up 3/4. And in 4 hours, they would be able to fill up 4/4, which is 1 whole. So it's going to take them 4 hours. That is the final answer. So you see, it makes sense. When Sandile works by himself, he takes 6 hours. When little Jacob comes and helps him, even though Jacob is a little bit slower, it still makes the total time less. Which type of numbers in the number system are defined by the following? Numbers that extend the natural and whole number systems by including the operation a minus b, where a is smaller than b. Okay, so when I read this, it's absolute nonsense and absolute garbage. I don't know why they're putting a question like this into an exam. But anyways, let me just try to explain. So you know how we've got on a number line, we've got the numbers, for example, -3, -2, -1, 0, 1, 2, and 3. From this point onwards, those are called natural numbers. Okay, so it includes numbers, or it doesn't actually, sorry, it includes 1, 2, 3, and so on. If I put a line there, then I'm including everything in between, but that's not what I want. So it includes the numbers 1, 2, and 3, and then onwards, like 4, 5, 6, 7, 8, 9, 10. Then if I include the 0, that would be what we call whole numbers. So whole numbers are the same as natural numbers, but they just include 0. Okay? Now they're saying, what are the numbers called that extend that? So that means goes even further back, that it extends beyond that. Or that would then include numbers like -1, -2, -3. What are those numbers called that are allowed to be negative? Integers. Integers. If you didn't understand this question, don't worry, it's weird. I don't understand why they're asking it. It's some weird definition kind of question. I wouldn't stress too much about this one. The following statements are incorrect. Write down the correct version. Okay, very easy. This you could literally go and type on your calculator. But let's say you weren't allowed to use a calculator. I mean, if you are, then trust me, just put a calculator. But if you aren't, then you must remember, this is a cube root. So we know that we've got squares and we've got cubes. So squares are things like 1 squared is equal to 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. You know, those are squares. Then you get cubes. 1 cube is 1. 2 cube is 8. 3 cube is 27. 4 cube is 64. So can you see that the cube of 64, or negative 64, would give us negative 4 as an answer. So, or you could even say, yeah, so the cube of negative 64 is going to give us negative 4, not negative 8. Now this you could just type in your calculator if you're allowed once again. For all of them you could, but let's say you're not allowed a calculator. A minus next to a minus becomes a plus. So -4 plus 6 actually gives you 2. Then here, if you type this in the calculator, it's going to give you an error. You're not allowed to have a negative inside a square root. But Kevin, here we have a negative inside a square root. No, that's a cube root. There's a difference. That's a cube root. That's a square root. You're not allowed to have a negative inside a square root. It's called non-real. Okay. And then here we have -5 squared. That is the same as -5 times -5. So 2 negatives make a positive. So it should be positive 25. Calculate the following. Okay, so this is for 3 marks. So if you do have a calculator, like if you are allowed a calculator in this test, you wouldn't just go type all of this in one step. You would do baby steps. So you would leave the 5. You could type that on your calculator. That should become 4, because I'm going to explain this for some learners who aren't allowed a calculator, and I'm also going to explain it for learners who are allowed a calculator. So if you are allowed a calculator, just put that in. If you're not allowed a calculator, then what is this? It's -2 times -2, which is a negative and a negative, which makes a positive. Then I'm just going to say -15 divide 3. So here we're going to think about multiplying. So that's going to give you 20. And then we still have this. Now, the biggest mistake you could make right now is to minus these two. Why? BODMAS. BODMAS tells us brackets of, and then division and multiplication go together, and addition and subtraction go together. So can you see that division comes before subtraction? So you must do division first. So it's going to be 20 minus, now 15 divided by 3 is 5. 20 minus 5 is 15. With this question, if you are allowed a calculator, to get 3 marks, don't put everything on the calculator in one step. But what you could do, I'll try to explain it with a calculator and without a calculator. So if you had a calculator, you could just go and put all of this in on your calculator and it will give you 6. If you don't have a calculator, remember that a minus and a minus is a plus, okay? And then here, what is 1 minus 4? You could type that on the calculator. If you don't have one, just remember that, or just try to get as -3. And then here we have 1 minus 4 again, -3. Okay, now, do not minus these two numbers because BODMAS. Can you see there is a multiplication over here first? So we can go 2 plus 4 minus, now what is 2 multiplied by -3? That would be -6. 2 negatives are actually just going to end up becoming a positive. Okay, now at the top you've got 2 plus 4, which is 6. 6 plus 6 is 12. Now 12 divided by 3 is 4, and then we've got 1 negative. So the final answer is going to be -4. So on a calculator, you could literally just go type that part in. So that would give you 6. And then you could type that part in on your calculator, give you -3. You could type that on your calculator. Then I would type in that on my calculator, which is going to give you that. And then I would have that, and then I would type that on my calculator, and it'll give me -4. So you could do little parts on your calculator, and your teacher wouldn't really be able to figure out that you're using a calculator. You're just showing the little steps along the way. This question says the exponential form of 25 is 5 to the power of 2. What does the exponent tell us? It just tells us there are 2 factors of 5 in the product of 25. Don't worry too much about that. You're barely ever going to see something like that. Okay. Represent the following in exponential. 7 to the 5th power. 7 to the 5th power. Rewrite the following expressions with positive exponents. Okay, many learners are going to get this one wrong. This is wrong if you do this. If you did this, it's wrong. The reason is, this -2 is only with the x. It's not with the 3. So leave the 3 as it is. And then if you want this to be positive, then you see how this x minus 2 is currently at the top. You need to put it at the bottom. There we go. That is the correct answer. Here, if you see this is negative at the bottom, you need to take it to the top. So that's going to be 2 multiplied by 5 to the power of positive 2. So as soon as you move it upwards, then this becomes positive. And if this one's negative over there, as soon as you take it down, it becomes positive. So as soon as you move it from a place where it was negative, it then becomes positive. Okay, and this is going to become 2 times, I think they want us to, it says leave your answer in the simplest exponential form. Yeah, so that would be your answer. Simplify for 4 marks. Now, guys, there are so many different ways that you can do this. There is no step-by-step way that I can tell you. There are so many different things you can do. Like, honestly, so I'm going to show you a particular way that I feel like doing it, but I don't even use the same method every time. I just understand the way the numbers work, and I know that one student might do it this way, another student might do it this way, but guess what? The final answer will have to be the same. And this is why I love maths. So your friend might tell you we need to do it like this. You might say, no, we need to do it like that. As long as you don't make any wrong things, like any mistakes, like things that aren't mathematically correct, you will eventually get to the same answer at the end. It might not look like it along the way. So you should try this question by yourself before you watch me, and then only check if you get the final answer, okay? And then if you don't, try it again and try it again until you get to the final answer. If you really cannot do it, then watch what I'm doing. I don't want you to watch what I'm doing and think, oh, it has to be that way. Okay. So the way I would do it is I would start in this bracket over here, and I would start with the minus 5. And I would use my calculator. What is minus 5 to the power of 2? But please put it in a bracket, because it's minus 5 to the power of 2. So it's minus 5 times minus 5. That is positive 25. Okay? Then I would move on to this w. This w currently has a little 1 over there. You can't see it, but we know it's there. So we know that these two numbers must be multiplied. So that'll be w2. The same with the z. There we go. I am done with that part now. Okay? The next part, I look at this. There's nothing we can do there. So I just leave it like this. This little dot just means I'm multiplying these two parts together. At the bottom, there is absolutely nothing I can do. Okay. Now, there are multiple things that you could do here. Some learners, they would want to maybe move this over here. You would maybe want to move it to the top because it's negative. I don't feel like doing that right now. I know that that would work, but I know that there's other things I can do. So what I feel like doing is I feel like multiplying these two expressions together. Okay? So I start with the 25 and the minus 2. A positive and a negative will give me a negative 50. Why am I not adding them? Because these two numbers here, they are not exponents. They are normal numbers. Okay, now I move on to the w's. Now these are exponents. And I know that when I multiply, then I must add exponents. Okay? The next part is the z's, or the z's, whatever you want to call it. 2, and then I know that there's a 1 here, and I must add those. That'll give me 3. Here I've got a 50 at the bottom, and a z. Okay, now, these two 50s can now cancel each other completely. So all that we're left with now is a minus. We still have that minus. We still have a w4. We still have a z3. And we still have a w minus 1 and a z. Now, one way we could do this is to realize that this is negative. To make it positive, we take it to the top. Okay? And then we still have z3 and we have z. Kevin, this one's also negative. Why didn't we take it to the bottom? There's a big difference. This is an exponent. That is not an exponent. Okay? There's a big difference. The negative is an exponent, and that is an exponent rule that tells us if it was negative at the bottom and you take it to the top, it'll become positive. If it's negative at the top and you take it down, it'll also become positive. Okay, now I've got these two next to each other, so that'll become w5. Okay, and now lastly, I should probably do something with these over here. So what does the exponent rule tell us? It tells us that when these two are the same, then what do we do with the exponents? Whoa, what happened there? Then we subtract. So it'll become z to the power of 2. And that is your final answer. That is what you want to get. No matter what method you use, you have to get that as your final answer. But as I said, there are multiple ways you could do it. Simplify for 5 marks. This is a lovely question. These are one of those where, now I've said this before and I'm going to say it again. The ways that I'm going to show you how to do this, you don't necessarily have to follow that exact procedure. Some learners do it in a slightly different way, but the final answer has to be the same. If you don't get to the final answer, then you have done something wrong. But there are different ways you can do it. So maybe you're busy studying with a friend and your friend does it this way, but you decide to do it that way. That is okay, but your final answers must be the same. That's the lovely part about maths, okay? It would be horrible if all different methods gave different answers. Okay, so what I would do is I'm going to go take every single one of these numbers and I'm going to use that shift fact method on my calculator. You know, for example, if you take 81 and you press equals, so you type in 81, you press equals, then you press shift, and then you press fact on your Casio calculator. it should say 3 to the 4. So I'm going to break that into 3 to the 4. I'm not going to do anything with the x plus 1. 5, if you do that, it actually already is broken down. You cannot break 5 down. It's already a prime number. The 3 is also a prime number, so I can't do anything there. If you do this number on your calculator, it'll give you 5 to the power of 2. Now, have a look what we've done. We've taken numbers that were completely unrelated. None of them were the same. 81, 5, 3, and 25. None of them are the same. Suddenly, we've now got 3s, 5s, 3s, and 5s. So we've got things that are the same. So we can combine them, and that is why we do that. We break them all down into their smallest numbers. Okay. Now, what does exponent rule tell us over here? We must multiply. So 4x, add 4. Remember, 4 times x and 4 times 1. Next one, leave it like that. Okay, and then what do we do here? Multiply. Now, there are multiple things that you could do here. Some learners, what they would do now is they would break this up. They would break it up into 3 to the 4x and 3 to the 4. And they would break this one up as 5 to the 2x and 5 to the minus 2. There is nothing wrong with that at all. It works perfectly, okay? In fact, I think I might even feel like doing that right now. But you don't have to. You can keep it all together if you want, and then just combine these two and combine those two. I'll do both, okay? So, method 1, and then I'll show you method 2. Okay, in method 1, I'm going to break everything up. You don't have to do both in the exam. You only have to do one of them. So I'm going to break everything up. So let's break up. So 3 to the 4x plus 4 is the same as 3 to the 4x and 3 to the 4. 5 to the 2x minus 2 is the same as 5 to the 2x and 5 to the minus 2. There's nothing we can do at the bottom, nothing we can do at the bottom. Okay, now what we could possibly do is everything that is negative, move it. So that 5 to the minus 2 is going to have to go to the bottom. I'll show you method 2 just now. So that's going to become 3 to the 4x, 3 to the 4, 5 to the 2x, 3 to the 4x, 5 to the 2x, and 5 to the positive 2, right? Because we moved it down. I actually like this method. So now, but you don't have to use this method. And some of my previous videos, I show a different method. There are so many different ways. I never use just one method. Now, I see that these two are exactly the same, so they can cancel. I see these two are exactly the same. They can cancel. That's lovely. And so we simply end up with 3 to the 4 at the top over 5 to the 2. 3 to the 4 is 81. 5 to the 2 is 25. There's your answer. Okay, now if you didn't like that method, well then I said I'll show you method number 2, where we don't break it up. So what we would do now is realize that these two are the same. So we can then say, I take everything up now. So I say the top one minus the bottom one, okay? And then I do the same with the 5s. Top one minus the bottom one. So I'm saying the top exponent minus the bottom exponent, because that is what the exponent rule tells us. It says that if you have a7 over a3, you must minus them. So if you have a 3 over there and a 3 over there, then you must minus these exponents. Top one minus bottom one. Okay. And if we then simplify, the 4x minus 4x cancels, so you just end up with 3 to the 4. Here we end up with 2x minus 2x, which cancels, so that's going to be 5 to the negative 2. Now, here I've got a 5 to the negative 2, so I don't want that to be negative. I want that to be a positive. So to make it a positive, I have to take it down, and there we end up with 81 over 25. Exact same answers. In a test, you only have to show one of those. Examine the first 3 diagrams in the diagram given below. Complete the table. Okay, so here we can see in this first position there are 3 points of intersection. That's why they've got a 3 over there. In the next one, there's 1, 2, 3, 4, 1, 2, 3, 4, so that's 8, 9, 10, 11, 12. So you see there's 12 over there. And then in this one, there's 9, 18, 27. Now, If you go and look at these numbers and these numbers, there is hardly any relationship. Like, I was really sitting and looking at this now before pressing play. There's hardly anything. But then what I realized is that there's 4, 4, 4, and then there's 9, 9, 9, and then there's 1, 1, 1. Those are all square numbers. 1 squared is 1. 2 squared is 4. 3 squared is 9. So the next one would obviously be 4 squared, which is 16, and there would be 3 of those. Because you see there's 3 1s. There's 3 4s. There's 3 9s. So there's going to be 3 16s. So that's going to be 48. The next one is going to be 5 squared, which is 25, and there's going to be 3 of those, which is 75. So it says describe the relationship. So what we can see is that the first diagram is going to be 1 squared, but then there's 3 of those, right? So it's 3 multiplied by 1 squared. For the second diagram, there were 3 2's, and each 2 was squared to become 4. In the next one, there were 3 3's, which were squared, and each of those, right, because there were 3 9's, right? And so there were 3 of those. And in this one, there were 3 of those. And then in the first one, there were 3 of those. So all that we can say is that you must square the position. So here we square 1. For this one, we square 2 to give us 4. This one, we square 3 to give us 9. And then you multiply that answer by 3. And then multiply by 3. Very challenging question. If you didn't get it, I wouldn't be too worried. This isn't a typical, although you could see something like this, it is very challenging. Numbers are arranged in the following pattern. If the pattern is extended, what will be the 5th number in the 100th row? Okay, the 5th number in the 100th row. So this is the 5th number, because 1, 2, 3, 4, 5, but in row 100. So row 100. So to go row 4, row 5, all the way down to row 100. So let's ignore this, and let's ignore this, and let's just look at these numbers. We can see that they're going 25, 31, 37. Can you see that we're simply adding 6 each time? So this is actually just a normal linear pattern. And we know that we can find the formula by just using Tn equals to An plus B. And we know that we would like to find row 100. So we want to find term 100. So we know that A is the amount that we are adding each time. So that's 6n. And then, n is 100, sorry. And then B is always going to be term 0. There are other ways of doing it. You can try using your own method, but you should get B as 19, because if I use the 0 method, if I had to come back one place, then you would minus 6, and this would be 19. And if you then had to go work this out, you would get 619. What is an algebraic expression with 2 terms called? So you need to know this. If it's a 1 term, we call that a monomial. 2 terms, think of a bicycle which has 2 wheels, so it's a bicycle. No, it's called a binomial. Then think about when you were younger, you used to drive, used to ride something with 3 wheels, and you call that a tricycle. So we call it a trinomial. So 2 terms is going to be called a binomial. What are x and y in the expression of this? Okay, so they are called variables. Simplify the following. Okay, so we're going to go step by step by step. On your calculator, you can literally type in square root 9, and that'll give you 3. Now, what are we supposed to do with these over here? Well, the exponent rules tells us that you take this exponent and you divide it by this number. If you cannot see a number there, it's a 2. So what is 4 divided by 2? That'll give you 2. And what is, now we move on to the y. 2 divided by 2, that is 1. So you just put a 1, or you can just leave it as y. And that is the answer. Simplify. Okay, so here we're going to multiply these two brackets together. I like to use FOIL, but you don't have to. I don't always use FOIL. Sometimes I just tell learners to go for this one, this one, this one, this one. But I think FOIL helps you to remember. So what does the F mean? It means first. So it's the first one in this bracket multiplied by the first one in that bracket. That'll give you x squared. Okay, now we move on to the O, which means outside, out or outer. Let's say outer. So the outside one. So it's the ones on the outside. So it's that one and that one. They are on the outside, on the very outside of this whole of these brackets. So if you multiply x with minus 3, you get minus 3x. Okay. Now we're going to go to the inside or the inner. Okay, so that's going to be the inside one. So it's those two. That's just going to give you 5x. And then the last one is L, which stands for last. So it's the last one in this bracket and the last one in that bracket. That'll give you negative 15. Now, can you see that these two both have an x? So they need to go together. You could even use your calculator. What is minus 3 plus 5? Well, that's positive 2. And there's your answer. We don't make this an x squared. We're not multiplying. We're just adding and subtracting like terms. Some learners, when they look at this question, they're going to be a little bit confused and they're going to think that it's one of these questions where it would look something like this. And then you would break this number into its prime numbers and this number into its prime numbers. This is not that. This one has minuses and pluses in between. So it's totally different. What we're actually going to do here is I immediately realized that that is a difference of 2 squares from factorizing. So even though the question says simplify, you can use factorizing within it to help you simplify. So how does difference of 2 squares work? Well, we need 2 terms. Let me write it down. Difference of 2 squares. Okay, so we need 3 things for it to be a difference of 2 squares. We need 2 terms. So here we've got 1, 2. We need it to be separated with a minus. There it is. And each term must be a perfect square. What is a perfect square? A perfect square is something like 9, 16, 25, 49, x squared, y squared. Why? Because 9 times 9 is the same as 3 times 3, 16 is the same as 4 times 4, 5 times 5, x times x, 7 times 7, y times y. See how it's always the same thing multiplied together? That is what we call a perfect square. The number 28 is not a perfect square. Why? Because 28 is 7 times 4, not the same. So I know that this is the same as 5 times 5 and z times z. Then this is the same as 3 times 3. So this part at the top is a perfect square. So what do I do if I know that it's a perfect square? Well, I put the square, so 5z and 5z, then 3 and 3. One of the brackets gets a plus, one of them gets a minus. It doesn't matter if you switch that around. What I can now see is that this is exactly the same as that. And so for my final answer, I'm left with 5z take away 3. Here they want us to factorize. It's only 1 mark, so it's probably just going to be 1 step. So it's going to be, can you see that there's a common factor of q minus r? So I'm going to take that out in the front. And then what are we left with? Well, if we take that out, then we're left with 3x and minus 2. There is nothing more we can do. That's the answer. Factorize for 3 marks. So when we factorize, I always like to start with common factor. Then we look at difference of 2 squares. Then we look at trinomials. And then we look at grouping. So if I look at this, I look for a common factor first. And I actually see one. I know that the number 2 can go into all of those. And I also see that I could take out an x in each of those. So I take out a 2 and an x. And so what am I left with? Well, I've taken the 2 out, and I've taken out one of the x's. So I now have 2 x's left over there. Here I've taken a 2 out, so I still have a 5 left over, because 2 times 5 is 10. Here we had 2 x's. I took one of them out, remember? So now I only have 1 left over. And then here I will still have a 14, because 2 times 14 is 28. I don't have any x's left over because I only had 1 here and I took it away. And so there we have that. That'll get you 1 mark. So we've done the common factor. Now I realize this is 3 terms with an x squared and an x and then a normal thing without any x's. That is a trinomial. And so I know that a trinomial would turn into 2 extra brackets. And let's talk about how to factorize this. So you look at the last number, which is 14, and you write out all of the ways you could write that. That would pretty much just be 7 times 2 and 1 times 14. You then look at these combinations and you think about which ones would allow you to make that number minus 5. How can you make a minus 5? You can make a minus 5. Well, you could think of about 7 minus 2, but that gives you positive 5. You could say 7 plus 2, that gives you 9. You could say 2 minus 7, that gives you minus 5. Ah, that's what we wanted. So we want the 2 to be a positive and the 7 to be a negative. So I put x and x over here because x times x gives me x squared. And then I put a positive 2 and a negative 7. You could also have switched it around. You could have also had the negative 7 first and then the positive 2. Doesn't make a difference. That is the final answer. They want us to describe this in words. Okay, so this is x, so just call it a number. Okay, so we could see that this part is first. So you're subtracting 5 from a number. So subtract 5 from a number and take that answer and multiply by 3 to get an answer of 16. Okay, and in words, yeah, maybe we should say 5. They're not too strict on that, to be honest. And then 16. Translate the following into a mathematical equation. Okay, so it says the sum. Sum means add. Half of a number. A number is x. Okay, half of it would be a half x. So the sum of a half x and 4 is then doubled and then decreased by 1 to give a final answer of 13. Okay, so the final answer must be 13. So they're going to say the sum of these two, so that's a half x add 4. They want you to take that answer and double it. So how do you double something? You just put a 2 in the front. That means double. Then they want you to decrease that by 1. So subtract 1. And that there would be your final answer. Here they just want us to solve for x. So very simple. What we do is we just take all the x's to one side, all the numbers to the other side. So I'm going to take all the x's to the left. So I need to bring that one over. And then I'm going to take this number to that side. So we're going to have 0.3x plus 0.4x. Why plus? Because when I bring this one over, the sign changes. Okay? On the right hand side, we have 0.7, and then it's going to be plus 2.1, because this negative, when it goes to the other side, it becomes a positive. Now, if you add these two together, you get 0.7. And if you add these two together, you get 2.8. To get x alone, you have to get rid of the 0.7, so you divide. And what you do to the one side, you do to the other side. And so that'll give us 4. Whenever we have an equation where the x that you are looking for is an exponent, these are called exponential equations. Okay, and the goal is to get to something that looks like this. For example, 5 to the x plus 3 equals to 5 to the 2, like that. When these two are the same, then you can ignore that, and then you can just say x plus 3 is 2. Or maybe another example, 3 to the 3x minus 1 equals to 3 to the 2x plus 4. When these two are the same, you can let go of it and just write it as that. So we got to get this and this to be the same. So how do we do that? The only way you can get things to be the same is to break the numbers down. So I know that 9 is actually 3 to the 2. How do I do that? Press the 9 on your calculator, press equals, press the shift button, and then press fact. So we break it down into little parts. So I break it into 3 to the 2. Okay. Now, the number 27, or 1 over 27, it's not going to work on your calculator. What you need to remember is that you are allowed to put this at the top, but all that it means is that if this was a positive 1, now it becomes a negative 1. So what I can now do is just go multiply these out. Now, I know that the number 27, if I use the shift fact method, my calculator will tell me that it's actually that. And things are looking good now, because I can now multiply these two, and there we go. I've got a 3 on both sides. I can then just ignore it, and so we end up with minus 3 take away 2, because when I take that to the other side, it becomes, you change the sign, and so 2x becomes negative 5. I then divide this side by 2 and this side by 2, and so x will be negative 5 over 2. The first thing you should realize is that we have fractions. Fraction, fraction, so immediately I'm going to write this as a fraction as well. We should know that when we have fractions, we need to get a common denominator. The common denominator here could be 15, the number 15. To get 15, I could multiply this by 5, and what you do to the bottom, you must do to the top. Because there's two terms here, I'm putting it in a bracket. To get this to become a 15, I would multiply by 3. What you do to the bottom, you must do to the top. And then to get this to a 15, and then what you do to the bottom, you do to the top. So now what we have is 5 to the 5x minus 7 over 15 minus 3, 7x minus 10 over 15. I'm just writing it a little bit bigger. 15 over 15. When we have an equation and the bottom is the same, you can let go of the bottom. So you can just write it now as this. And now we have a simple equation that we can now go and solve. And so we can now start by multiplying the 5 inside here. So that'll be 25x take away 35. And then we multiply in here. So that'll be negative 21x add 30 equals 15. Now I'm just going to combine these two together because they both have x. So 25 minus 21 is 4. I'm then going to combine these two. You don't have to do it this way. You could take them over first and then combine them. It doesn't really matter. Okay, I'm then going to take this over to the other side where it will become positive 5 because when you take things over, they change sign. And so we now end up with that. To get x alone, we divide both sides by 4 and x is 5. The square of a number. A number, we will call that x. So the square of x is x squared. If you add that to twice the number, okay, so if you add that to twice the number, what is the number? We said the number was x. The answer should be 3. There we just made our equation straight away. So x squared plus 2x equals 3. And now we need to solve this. You need to identify that this is a quadratic equation. So what are the rules when we have a quadratic equation which has that x squared that doesn't cancel out? We have to, step 1, take everything to one side and make your equation equal to 0. So I'm going to take everything to the left. So I'm going to bring that 3 over. Step 2, factorize. And factorizing could be multiple things. It could be, let's say A, it could be common factor. It could be difference of two squares. It could be a trinomial. Or it could even be grouping. This is just a normal trinomial because we can see we've got an x squared, an x, and then a normal number. So the way that that trinomial works, or trinomials work in general, is you take this number and you write out how could you make that? You could say 3 times 1. That's sort of all you could do, right? You couldn't make it anything else. So how would I combine these two numbers to make that? How would I make a 2? Well, I could say 3 minus 1. So we're going to put x over here and x over here, because x times x must give us that one. And then I said that the 3 must be a positive, because it's positive 3, and negative 1. Now, we would go a little bit further. We would now say that x plus 3 is equal to 0, or x minus 1 is equal to 0. Now I'm going to go solve and solve. So to solve this one, I take the 3 to the other side, and there's my answer. To solve this one, I take the 1 to the other side, where it will change sign to become a positive 1. And there's the answers.